Hi everyone, my name is Srinivas Makam. I'm one of the Docker captains. This video is part of my Docker networking tips series. In the first video, I covered Mac VLAN network driver. In the second video, I covered load balancing options in Docker. In this video, I would cover Docker networking troubleshooting techniques. So as we all know, networking is complex, and debugging networking issues takes a lot of time, and specifically with containers, debugging is even more difficult, considering that containers don't have all the troubleshooting tools. So the way I look at it is I typically approach this problem at three levels. The first level is where I typically use the debug commands that Docker provides. Those are typically the container level, service level, or network level debug commands. So that is like the first level of troubleshooting. In the second level of troubleshooting, typically what I do is use a troubleshooting container. In this case, this is one of the troubleshooting containers I like. So this is available as a GitHub project, and this particular troubleshooting containers all the networking debug tools that we are all familiar with, like TCP dump, PyPerf, netstat. And this troubleshooting container can be attached to any container or to a network namespace, and we can run our usual set of commands. The next level of troubleshooting normally I have done is going to a network namespace, and within the network namespace we can run our usual Linux commands, like looking at the route table, ARP table, VXLAN table, IP tables, even IPVS related tables. So this is like if we really have a low level problem, it is it's pretty good to go into the network namespace and debug. For this troubleshooting video, I'm going to use a simple a client-server application. Client in this case is a Ubuntu container. It's a variation of the Ubuntu container. The server is a Oat server, and I have two replicas of the Oat server. So here I have created an overlay network over the Swarm cluster. I have created a client service with one replica, and then I have a Oat service with two replicas, and I am publishing the Oat service using ingress mode into port 8080 in the host machine. So this is how the packet flow would look like, where we access the Oat service from the client service. From the client, we access the service name that gets mapped through DNS to the service IP, and then using IP tables plus IPVS, it gets load balanced to the two Oat containers. Now the same Oat service can be accessed from the individual Swarm nodes. When we access it through the Swarm nodes, we access using the ingress network. We access it using the host name :port that gets mapped through NAT to the sandbox IP, and from the sandbox it gets routed to the IP tables and the IPVS, and it gets load balanced to the two Oat containers. So from the networking perspective, so these are the two nodes of the Swarm cluster, and based on how the Swarm would load balance, the client and the Oat containers get pushed into different nodes. For this particular example, I've said client is on node 1, the two Oat containers is on node 2. The sandbox is a network namespace that is used for the ingress routing mesh. So what I tried to show in this picture is the client, and so there are three networks. There is an overlay network, there is an ingress network, and the Docker gateway bridge network. The client and the Oat containers are part of the overlay network. The sandbox, network sandbox, as well as the Oat containers are part of the ingress network, and this is how we are able to access the Oat containers from any of the node in the Swarm cluster. The Docker Gateway Bridge is used for exposing the containers in the overlay network to the outside world. And this is also used in the publish mode host. And all the containers are part of the Docker Gateway Bridge network. So enough of the theoretical part, we'll get into the demo portion of this. So I have a 2-node Swarm cluster. So let's first look at my Swarm cluster. Swarm 1 is the leader node and Swarm 2 is the other node. I've already deployed this client and the OAuth service. So let's look at the services. There's one replica of the client, then there is 2 replicas of the OAuth, and we can check where the client is deployed. The client is deployed on Swarm 1, and if you look at where the OAuth service is deployed, one instance of the OAuth service is on Swarm 2, another instance is on Swarm 1. Now let's look at what are the networks that are created. Except the My Overlay network, all other networks are created by default. So let's look at how. So typically, what I start off with is let's do a Docker network inspect of the bridge network. So we will look at the the important characteristics here. So this is the bridge network. This is the ID. It says the driver is the bridge. I have disabled. I don't have IPv6 enabled. And for this particular bridge network, so this is the subnet that is used. So any containers that is part of the bridge network would get IP address within the subnet range. Currently, I don't have containers running in the bridge network, so that is why there's no containers showing up. So now let's look at the overlay network. So let's look at what are the interesting things here. So this is the name, this is the ID of the overlay network. So see here the scope is in the Swarm. So when we create an overlay network in one node of the Swarm cluster, the overlay network is visible on all the other nodes. That's why the scope says Swarm. And from an IP address perspective, so this is the IP address range that is assigned to the overlay network. Any container that is assigned to this overlay network will get an address in this network namespace. And if we look at what are the containers that are part of this overlay network, there is vote.2, there is a client.1, and then an overlay sandbox, which is a sandbox associated with the overlay network. So if you look at Docker PS, so we see that in this particular node, we have one instance of the OAuth and one instance of the client, and those are the 2 containers that are shown up here. So next, let's look at the service level. What is the interesting networking properties? So let's look at from the OAuth service. Associated with the OAuth service, the important things which is from a networking perspective, one is this particular service uses the mode VIP. This is the target port of the service, and this is the published port of the inside the host. And so this is an important thing. What is the virtual IP that is associated with this OAuth service? And we see 2 virtual IPs. That is because one virtual IP is in the overlay network, another virtual IP is in the ingress sandbox through which this particular service is exposed. If we look at for the client, that will not have a virtual IP in the ingress sandbox because this client service is not exposed directly to the outside world, but otherwise the mode is a VIP for also the client service. So next what we'll do is we'll SSH into the the client and the OAuth containers, and we'll see the similar IP information. So here I have first let me get into the the client container here. So if I do an ifconfig here inside my client container, I see 2 addresses. One, this is in the overlay network. This is in the Docker Gateway Bridge network. So those are the 2 IPs, and the other is the loopback address. Now let me do the same thing for the OAuth container. Okay, so we shall do ifconfig. So here we see three IPs. This one is still the overlay network. This is the Docker Gateway Bridge network. The third one that we see that is specific to the OAuth container is the Ingress sandbox IP address. So this is, I would say, the first level of troubleshooting that I normally do, where I do a different inspect commands, go inside the container, make sure the IP address is present correctly. And just one more thing that we could do is in this case, I have also already inside my client container, just to show that this application is working. If I access my OAuth service, I'm able to see that you can see the container ID changing. It gets load balanced between the two OAuth containers. Assuming that I'm not able to find out the root cause of the issue that I'm debugging with level 1 debugging, so let's go to the level 2 debugging actually. So as I mentioned earlier, typically I use this debug container, which can be attached directly to the container or to the host machine or to the network namespace, and we can do a whole bunch of troubleshooting. So you can find more details about this in the particular GitHub page. So here, it has pretty much all the favorite tools that we would, typically want to use from a debugging perspective, a network debugging perspective. So what we will look for is, we will access the OAuth service from the client and check that the packets go back and forth from a container level. First we look at it from a container level, then we look at it from the host level. So I'm in the node 2 of the Swarm cluster. Here one instance of the OAuth service is running. So what we'll do is we'll use this troubleshoot container, and in the network specification of the Docker, we will use the the OAuth client. So now we are inside the container, which is the OAuth container, using this troubleshoot container. So if you look at the ifconfig, it shows all the IP addresses associated with the OAuth container. So to check the ping traffic, so let me do a TCP dump on ETH2, which is my overlay port, on port 80. So then what we will do is we'll go back to node 1, and what we'll do is we'll exec into the client container, and then we'll try to access the OAuth service or the container. Okay, so I still don't have any packets captured, so let's me do a capture. Okay, so now we can see the packet captured. So this is the overlay network source IP from the client, and this is the destination, which is accessing the service in port 80. So now we know that at the container level, at the overlay network level, packets are going back and forth. So if you want to debug at the Ingress network level, we can do the same thing, but what we can do is we can use TCP dump at the different port level. So we could do ETH0, which is the sandbox port, and we can use the port 8080. And if you do, so at this point we don't have to go to the client container, we are in the Swarm node itself, and here we can do curl localhost 8080, because that is where the service is exposed locally. And let me see, I think okay, so if I do that, now I can see that here the source IP shows, which is a sandbox IP, and it is access to the port 8080. In the previous case, we saw that this is the overlay network, subnet. The difference here is it is in the sandbox subnet. The reason being, I am accessing it using the Ingress routing mesh. In some cases, let's say that we don't see the packets coming to the container. So where do we go next, right? We want to check if the packets are being exchanged at the host level. So to do that, what we could do is we attach the same debug container to the network host. So in this case, instead of attaching to the container, we are attaching it to the host. Once we attach it to the host, we should be able to see all the IP addresses that is at the host level. Now in this particular node, the ETH1 is the interface that is used by the Swarm to communicate between the two nodes. So what we will do is we will do a TCP dump at that particular interface, and then we will try to capture on port 4789. What is 4789? So that is the VXLAN port. The packets that is exchanged over the overlay network gets encapsulated into the VXLAN protocol. So that is why we are capturing on the port 4789. Now we can do the same curl here, and we should be able to see packets going. Yeah, so now we are able to see packets going back and forth. So what is the interesting thing that I want to show here is that this is the underlay network, and it is being sent to the destination port 4789, which is the VXLAN dest port. So now we know that at the host level things are working fine. So this is kind of typically how we can isolate the problem at the container level. Maybe there are some problems, then there could be some problems at the host level. We can kind of narrow it down to the the right section of the problem. So this concludes our level 2 troubleshooting. The last one is the level 3 troubleshooting, where typically I use in cases where there are issues at the route table level, at the VXLAN table level, or at the IPVS level where load balancing tables are not populated correctly, or at IP tables which is used for filtering, that is not programmed correctly. So that's kind of pretty deep into networking debugging. So that's kind of what I would call it as a level 3 troubleshooting. So I will cover 2 examples with a level 3 troubleshooting. The first example, we'll get inside an overlay network namespace, and we will look at how the VXLAN flow works end to end. And the second case, we would get inside the container network namespace and try to follow how load balancing works end to end. And what is the namespace associated with the my overlay network. So what we have seen is these are all network namespaces with my overlay network. This is the ID, which is basically this is the network namespace associated with it. So first what we will do is we will start the troubleshooting container in the we have started in privilege mode. So let's do that. And then the network ID we want to associate here is the network namespace that we've kind of already found here. So let's start with that. So at this point we are inside the network namespace of the overlay network. So now if you look at ifconfig, so this is where we would see the VXLAN interface. Otherwise, previously we were not seeing the VXLAN as one of the interfaces. So we see the VXLAN interfaces. Now let's say if we do a brctl show, we see these, there is a VXLAN interface, and then this is a bridge associated with it, and the 2 VETH interfaces that are part of the VXLAN bridge. There we can look at details like ARP table, route table. So let's look at some of these details. So this is my cheat sheet, so I normally refer here. So first is, let's look at the the ARP table to see how that looks like. So this is my ARP table, and these are the addresses in the overlay network, and we see that the next hop is the VXLAN interface associated with this particular IP address. Then we can look at the encap detail. So if we see the encap detail, we would see that to reach this particular MAC address associated with this IP address we saw here, we need to go using VXLAN to the destination, which is the underlay network. And we can also find details at the what is the VXLAN ID used for this path. Typically I use this particular command. So for this particular VXLAN interface, what is the VXLAN ID which is used, and a lot more VXLAN properties we can find at this level actually. So this example showed us how we can get inside the overlay network namespace and debug anything with respect to the ARP table, route table, forwarding table from the VXLAN perspective. So the last part we will look at is how do we look at from IP tables as well as load balance perspective. For this, we need to first get inside the network namespace of the container. So these are the containers running on node 1. So first we will try to find the sandbox associated with this particular container ID. We look at the client container ID. So this is the sandbox that is associated, and then we can find what are the network namespaces and then associated with that particular sandbox ID. So here, this is the container. So this is the network namespace I want to enter. So I have run the the troubleshooting container in privilege mode, and in the network ID that I am going to use, I'm going to use this particular network ID. Okay, so now I'm in the I've done an NS center. I've gone inside the container networking namespace. So to look here is how does the load balancing happen? So it uses a combination of IP tables and IPVS to do the load balancing, and the mangle table of IP tables is being used. So what we see here is if the destination is 10004, we mark it with a particular filtering rule here, and if it is destination is this, we mark it with a different filtering rule. So that filtering rule gets carried as a meta tag inside the packet. Now if we look at what IPVS admin shows, if the filtering rule is 258, which corresponds to this is 102 at the hex, then that packet does a round robin load balancing to these two particular IP addresses. So this is pretty much how the load balancing is done using the Linux kernel feature, which is the IPVS. So as part of the network namespace part, in the first example we covered getting inside the overlay network namespace. In the second example we covered getting inside the container network namespace. We can also get inside the ingress sandbox to do similar kind of debugging. So that concludes my level 3 troubleshooting. Hopefully using a combination of these troubleshooting techniques, we can debug most of the container networking problems. So as part of this slide deck, I've also mentioned what are the typical debug commands that I use, more details about this debug container and some of the common commands, as well as inside the network namespace, what are the typical commands that could be useful for debugging. And I've put some of the references that I've used. Yeah, thanks for watching. I hope you enjoyed this video.